My name is Yves, founder and managing partner of the Python Quants. First of all, a big thank you to the organizers for such a great conference. I will speak about streaming financial data and plots with Plotly. First, a couple of words about what we do. This is the infographic that says it all. It's actually 7 things. So we are providing services to the financial community. We organize events. For example, next week I will be in Manhattan, where we have our For Python Quants bootcamp over 4 days. We provide certification. I will say a couple of words after that about this. I have written and published 3 books on the topic, Python for Finance. We work in open source as well, so we have our open source library, DX Analytics, but all the codes from the books and many, many more things are in the open source domain. We run a platform which is called the Quant platform. We have close to 10,000 users on the platform as of today. And the main topic, this is on the left, and here you see it in the middle, is training. So online training, live training, events, corporate training, customized, standardized. So it's currently almost all centered around the training space in Python for Finance. Yeah, that's me. If you're interested about what I'm talking on, usually you can visit hilpisch.com. That's my private website. There you find many videos, many talks, slides, etc. These are my 3 books. I might be best known for the middle one, O'Reilly, in the tech community. Python for Finance has sold pretty well. I looked it up. The GitHub repo has more than 300 stars, so I learned that this is kind of good already. I know on the platform we have a couple of thousands of people that use the code from the book on the platform. The other ones are more quantity. Derivatives, analytics, and listed volatility, so this is even more niche. The middle one has, I guess, the broadest appeal in the industry. Topic-wise, similar to what Quantopian does and what Jess has been talking about earlier, we focus these days mostly on Python for algorithmic trading. So here you see one of our popular courses. It's called Python for algorithmic trading. You see a screenshot from the Interactive Brokers trading terminal and also a little bit of static content. So this is what we do, for example. We've just launched this week, and somebody got this email, he told me during lunch, the university certificate in Python for algorithmic trading. So this is brand new. We cooperate with universities and other partners to make possible what we all do, and here are a couple of them. Thomson Reuters, for example, Jorge is here from Thomson Reuters. They regularly host our big meetup in London. Without such sponsors, this wouldn't be possible. Fitch Learning and the CQF Institute, they are the partners for our For Python Quants bootcamp in New York. I'm happy to work with them on that, and also our local university, HTW SAR, which cooperates with us on the education side of things. What I'm going to talk about, not only talk about, I will do a little bit of coding and writing, is about real-time streaming data. So far all the talks I've been attending, they focus more or less on historical or static data. So I usually, when I teach, make the distinction between 4 different types of data. The one is historical unstructured data like news or the Twitter feed that we all know, or Facebook postings and so forth. The other one is then real-time, that you say, well, of course there are tweets coming up and you see it here, you got new tweets, you got new messages, new email and so forth. These are the 2 things. I can remember that somebody talked about the text analysis and visualization in this regard here. But what we have seen is many talks about historical structured data. In particular today, for example, Jorge focused on this part, stock prices, P&L or corporate information. Jess in her talk focused on historical data in the context of backtesting strategies and evaluating strategies. I will focus on real-time structured data, because when you think of the traders these days that are sitting in front of their Bloomberg or Thomson Reuters terminals, they watch what is coming in. And not only the people are sitting in front of their screens, the machines are crunching the numbers in real time. And one of the issues is not only processing this data, no, it's also the visualization of this data, because you want to have a real-time look at what is going on. And this is what I'm going to focus on. If you're interested in what I'm going to do, I have posted, or what I show here and what I will do right now, I have posted this on my Twitter handle DYGH. You can look it there up. There you find the links to everything that you see what I'm doing here. So a gist I have created, as well as the slides are available on my Twitter feed. Should be my latest or second. No, I tweeted about Jorge's talk, so I'm sure you find it. You find it not that hard. So let me start and set the stage with the static data. It says streaming financial data and plots with Plotly, but the subtitle is interactive financial plot with Plotly. So let us start with the very basics. When I execute these cells, this is still the standard notebook, I have picked out this very first example from the Plotly page. We all know this is nicely interactive. We have these Hoover effects and so forth. That is one of the reasons why we use it. And when we work with real financial data, what the standard still is in our space is that we use matplotlib in the Python community. It's the go-to library and the most commonly used one. Of course, there are many, many more. We have seen a couple of them today and during the last 3 days in total. So when I read data, for example, here from Yahoo Finance, for Amazon historical data, I'm still in this historical world, and use now matplotlib to visualize that, what I get is a static plot. And you see this is going through the roof. I don't know, it's in the top 5 in the world right now, Amazon, with regard to market capitalization. But this is a static bitmap. It's a binary file. I cannot do anything. This is not data-driven. This is just a snapshot of the data in that sense. And then we have seen from Jorge that there is this fantastic cufflinks library, which makes the interactive charting capabilities of Plotly available to pandas. So when I now do the same thing, and you notice maybe the little difference, here I do dot plot, this is the method, and instead with cufflinks I do dot iplot. Takes now a bit. I'm using here the server capabilities, and you see I have a similar chart, but now I have all the nice interactive capabilities. And for us financial guys, is here I have 4 time series here, open, high, low, close. And in this chart, most of the information gets lost because I cannot see what really is open, high, low, close. They are so close together on a daily basis, and here for this long period of time that I visualize that I cannot see anything. But we know with D3GS I can zoom in, I can say, well, over this period, how did this evolve? I can zoom in and so forth. So you know all this, but still this is static data. The same holds true, just another example, when I want to generate a histogram, I can do this with matplotlib, but this might be a little bit nicer here. That's the stage. This is historical data. We have seen quite a bit in this regard. What I'm now going to do is to first implement my own financial market, which spits out data on a constant basis, but at random times, because usually the arrival times are random and not kind of nicely spaced. So when we think in terms of financial time series data, we have something in mind like daily bars, 1-minute bars, 5-minute bars, so homogeneous data sets, but in the real world, data arrives at heterogeneous time intervals, and this is what I'm going to simulate. I will write a little program, actually 2 or 3 scripts, and my end goal will be that I have this Hello World Flask example here, which in the end will host a interactive or a streaming plot. So let me first do the tick server side of things. So tick data server. What I'm using, and we saw it already, this is heavily used in the Jupyter notebook world. I'm going to use ZeroMQ for my example. ZeroMQ, import time as well. I'm going to import random. Context, ZeroMQ, context. Now building something according to the publisher subscriber model. So I will have one publisher. This is my financial market. This could be in practice Bloomberg. This could be in practice Thomson Reuters or the exchange directly. Bind it to a port, and now let me do it with my other example, Amazon actually, and I have a starting value of 100. This is not just normalized. What I'm going to do is in an infinite loop, let me, this is a little bit creator. I will now change in a random fashion the value. Amazon, let me do it that way, plus equals random, Gauss, 0, 1, and maybe just half of that. So this is a random walk that I program here, so nothing should be to earn for an algorithmic trader because this is completely efficient. The next thing is that I will send this over the ether. I create a message. This is just a symbol that I put in here, a plank, and then the value that is created here. So I have Amazon as the symbol. The next thing is that I say socket send string message. What I'm want to do as well, just to have an overview, is I print this message, the command line, and as I said before, this doesn't arrive in a homogeneous fashion, it arrives in a heterogeneous fashion, so I will put this loop to sleep for a random amount of time. So random, this gives me random numbers between 0 and 1. Let me maybe multiply this by 2. So ZeroMQ time random. My context object, the main object here, the socket according to the publisher protocol. I bind it to the port 555 here, my local host, and then I have this random walk which I publish. If everything goes well and I save this, I should be able to run this, and I have my server running. This is now my financial market I can work with. And this is not too far away from reality. Sometimes I get a couple of observations within a second, sometimes it takes a little bit more than a second, so I never know, but I need to digest it anyway. So nobody says when something arrives and how many things arrive at a certain time interval, but this is what we need to digest in real time, online, as they call it in the computational world. So let me go back to my editor and now write a little tick client. This is even a little bit easier actually, so tick data client, import ZeroMQ is actually the only thing. No, what I also need is datetime. I want to timestamp what I receive. So context. Context. This is now a subscriber. So instead of pub, I use sub. It subscribes to another socket. Socket connect to TCP 000. 5, and I should say to what it subscribes. So I could have multiple streams for Amazon, for Microsoft, for Yahoo, and so forth. So I need to define what I want to subscribe to. So set sock opt string, a little bit cryptic. ZeroMQ subscribe, and I simply subscribe to everything. So if I would pick out from a set of symbols just one, I would now write in Amazon, but empty string means to everything. Infinite loop. My message is socket receive string. And I will going to timestamp this. And I'm going to print strt plus. I wouldn't need this anyways, but let me do it a little bit nicer in the way plus message what I receive. Have a quick check. Looks kind of okay. I'm receiving the message, I timestamp it, and I print both things out. So the first client here, Python tick client. And you see on the right hand side I have now the first client receiving, and this whole model is all about that I probably have a couple of these clients, and ZeroMQ can manage thousands at the same time. So you see now the typical model, Thomson Reuters is sending out tick data and a bunch of financial institutions are receiving it at the same time. So that's the model here. And now we want to go and visualize. We can receive the data, now we want to visualize this in real time. This is the major problem here. And let me first copy tick client to tick plot. So I have a copy here. Now I need all the plotly stuff, so I import plotly as PLY. What does it usually do from plotly graph objects imported all, import plotly tools as PLS. I need the stream IDs now. From the credentials file, this is called stream IDs. So my socket is as it is. I don't need to change anything here. Now I need to do the plotly stuff. The first is my stream object. So I set number of points to maximum of 100. The token I'm going to use is the first one. Then I have my trace. This is a scatter plot. I don't have any data when I start out, so this is empty. Y is empty. Name is tick data. Mode is lines plus markers. And the data comes from the stream, so my stream is S. Now the data itself, the data object, I have only this, this one trace, so it's a very simple object. The layout, I can do many things right now here, you might know this all much better than me. Title, I say just tick data stream. And the figure object now is, of course, data and layout. And I can go and plot this. For example, PLOTCON. And auto open true, so I want to see it in my browser. I need the other stream object as stream IDs. And this should be it for the preparation. So it's not that simple, but still for the result that we expect, it's also not too involved to get a real-time streaming plot. So let me quickly check. I have stream, scatter, data, layout, figure. You are my Python interpreter here. If you spot anything, feel free to raise your hand or to give a shoot out. So this is also okay. I'm receiving the message. I timestamp it, but now I need to split the message. I have the symbol on the one hand and the value on the other hand. So my message, good in time, needs to be split. I can still print it out, no point in that, and st right now, and I write this as a dictionary. X value, this is time, that's my time step, and plotly understands my datetime object, and the y value now is the float version of the value, because everything above is a string. So I'm sending strings, I'm receiving strings, I'm splitting strings into two strings, so I need to transform this now into a numerical value. st right, x, t, y. I cannot spot anything, so I hope the best for the best, like always. So let me stop that one. Python tick plot. Proof lies in doing it, especially when you have this spotlight on yourself. And here we go. Indeed, it works. So I'm on the Plotly webpage, and you see now in real time, actually you see local times here, the 21 or 9 p.m. It's obviously not our time. This is coming from here my notebook and what I'm using. And you see here with Plotly that it works, and I have my streaming plot in real time. It's not actually financial data, but it's very similar to what we have. I said my end goal is to have this in my Hello World example. So when I go up to this, here to the Hello World, and what I can do now here is I frame that, add that. But what I need is this, the size, width. Let's use double quotes here. Height. Example, so let me check, and let me in particular look, it's on port 999, so I'll write this down now. So my Flask app is now running, and when I change here to add 127 Oh, there's another thing that was saved, but I simply use that one. Say it again, please. Ah, yeah, so it's sure. Yeah, I've put it in the. It doesn't. It belongs within the. Of course. Yeah, sure. Thank you. This belongs in here and not in between. That's completely right. Well, does it make sense? So with Flask and debug mode, you see it updated itself. And here we go. And I have my little Flask app now with the plot in here. Did it stop streaming? No. I don't know why it doesn't stream. Did I put in the right one? Oh no, this is not my, that one here. I don't know why it's not streaming. Well, the final thing does not work, but the file name that I used for it, file name is PLOTCON. That is not the one that I put in here. This is kind of a little bit strange. Yeah? Yeah, it's a different, no, this is not the thing. I've chosen here a different file name. I don't know why it shows in the title. Let me quickly check that one. Last thing I want to check, then I'll leave you without it maybe, because it's not the major thing I wanted to show. It shows only static version of it. I don't know what's happening here, why it's not updating, but it should be. But I think you guess the point, or you see the point. It's not that hard to work with streaming financial data on the one hand side. So here I have also a notebook open, which I'm going to restart and hope that it works, because it retrieves now real financial data from a European online platform. Where at these trading hours I see 5 minutes, but this I'm already at the closing point. I have also static versions of it. So what we should see, this is a static version, a GIF animation of the tick data example, and here is a GIF animation of the euro US dollar bid and ask prices. I recorded this this morning. Actually, this is what this shall create, but you see it's still here. We are after trading hours, though there are not that many ticks anymore. So unfortunately, in the time zone we are here is the worst time. In New York, it usually works at that time still, but here we don't have that much streaming data. The very last point that I have for you guys is a quick look at a library that we have. It's not actually a library, it's a wrapper class around the streaming API, because as you have seen me typing, it's kind of a little bit involved, so I need a couple of lines, and for many people that just want to do interactive analytics, it's well too much. So we have written a little piece of code, and this is what I'm using here. I instantiate an object of this class, which is called TPQ PLY. I add a data source here, and my tick data is still running. Localhost port 5555. So I connect to the data source. I add a scatter trace here, and can now within my Jupyter notebook embed this with kind of the regular code once I have the URL of my plotly plot. And when I now start streaming, call the start streaming method of the object, you see that it's now streaming on the basis of the data that it retrieves. So this is, I guess, I would say a little bit more Pythonic for people who work in interactive financial analytics. Might be a little bit easier to have these 4 lines of code to set up such an object. And the wrapper class is much more powerful, so you can handle subplots, multiple streams in a single plot, and so forth. So I wouldn't call what the wrapper class can do dashboard already, but it's close to that. That you say, well, I have a couple of streams there of real-time data streams. I want to update them in real time, and it's made kind of easy. So here I just stick to the very simple example. This is still my financial market here, Amazon 94 or whatsoever the current quotation here is, the current prices of the stock, 94, and you see this updated here in real time. But it should, here it stopped working because I'm using the same streaming API, therefore it's just with this one stream ID. Via the same streaming API, I can just handle one live stream. So that brings me to the end. We've gone through the live example. If you're interested, I can also provide the GIFs here, and if there is time, I'm more than happy to take a few questions. Thank you.